Good morning, students. In the today's session, we'll start learning about the quality of service. This is one of the very important concept and the methods we are going to implement for the quality of service. And most of the questions in exam point of view, you can expect from this topic. Now here, what is meant by this quality of service? In an internet working issue, there are four main characteristics which are related to this quality of service. One is a reliability, delay, jitter, and band. What is meant by this reliability? Here, if the reliability is less, automatically the quality will decrease. Okay. The lack of reliability means that losing a packet or acknowledgement which enters the data transmission. That means email, file transfer, and internet access are the reliable transmissions. Okay. And what is meant by this application delay? The applications can tolerate delay in different degrees. Telephony, audio conferencing, video conferencing, and remote login. For all these things, we have some minimum delay will be there. Okay. And what is meant by this jitter? It is the variation in delay for packets. Okay. That means if 4 packets depart at times 0, 1, 2, 3 and arrive at 20, 21, 22, 20. That means here we have a 20 units of time we have a delay. Okay. The audio and video application accepts the delay of packets as long as if the delay is same for all the packets. Okay. And now here, what is meant by this bandwidth? Different applications need different bandwidths. In video conferencing, it needs to send the millions of bits per second to refresh a color screen. Okay. While the total number of bits in email may not reach even a million. Now here, what are the techniques which we have to follow to improve the quality of service? The first technique is scheduling. Second one is traffic shaping, admission control, as well as the resource reservation. What is meant by this scheduling? The packets from different flows arrive at a switch or router for processing. Several scheduling techniques are designed to improve the quality of service, such as here this first in, first out queuing, priority queuing, and weighted fate queuing. These are all the several scheduling algorithms which we can implement to improve the quality of service. And here the first one is what is meant by this FIFO. Especially this first in, first out, we are going to use in the queues concept. Okay. Here, because in FIFO queuing, the packets wait in a buffer queue until the node or router or switch is ready to process. Okay. And it always follows the first in, first out concept. Okay. And if the average arrival rate is higher than the average processing rate, here arrival rate is more. Okay. And the processing rate is less, then the queue will increase. Yes or no? Will fill up with new packets will be dispatched. And what is meant with this priority queuing here? In priority queuing, the packets are first assigned to a priority class. Each priority class has its own queue, and the packets in the highest priority queue are processed first. Then the packets with the lowest priority queue are processed. The system does not stop serving a queue until it is empty. Now, what is meant by this weighted fate queuing? In this technique, the packets are still assigned to different classes and admitted to different queues. The queues are weighted based on the priority of the queue. Higher priority means higher weight. And now here, the system processes the packets in each queue in a round-robin fashion, with the number of packets selected from each queue based on the corresponding weight. Okay. And here based on the weight, it is going to take the packet with a priority. Now here, what is meant by this traffic shaping? The traffic shaping is a mechanism to control the amount of traffic and the rate of traffic sent to the network. Here we have mainly two techniques that can shape the traffic. One is a leaky bucket, another one is a token bucket. In exam point of view, you can expect any of these concepts, either leaky bucket or token bucket. What is meant by this leaky bucket? If a bucket has a small hole at the bottom, the water leaks from the bucket at a constant rate as long as there is a water in the bucket. The rate at which the water leaks does not depend on the rate at which the water is input, because here, unless the bucket is empty. Now in networking also, we have a technique called leaky bucket can smooth out the bursted traffic. because the bursted chunks are stored in the bucket and sent out as an average rate. Here we have one after the other. Only the fixed flow will be there whenever if we have the leaky bucket. You just see the steps here in the above figure. The network has committed a bandwidth of 3 Mbps per a host, and here it is going to be have 3 Mbps. That means only the equally it will transmit. Okay, here the fixed data is going to be transmitted. Now, here in the above figure, the network has committed a bandwidth of 3 megabits for a host. Okay. The use of the leaky bucket shapes the input traffic to make it conform to this commitment. Now, the host is going to send a burst of data at rate of 12 Mbps per 2 seconds and a total of 24 megabits per of data. Okay. Now, the host is silent for 5 seconds and then sends the data at a rate of 2 Mbps per second for 3 seconds, or a total of 6 megabits of data. In total, the host can send 30 bits of data in 10 seconds. Here, whenever if we have a leaky bucket, it smoothen the traffic by sending out the data at a 3 megabits per second within the same 10 seconds. Now here, without the leaky bucket, the beginning burst may have hurt the network. Here, without the leaky bucket, the beginning burst may have hurt the network by consuming more bandwidth than it is set aside for the host. This way, the leaky bucket may prevent congestion. Now, here, consider the below figure that shows the implementation of the leaky bucket. Here we have a FIFO queue. It holds a packet. The traffic consists of the fixed size packets. Then the process is going to remove a fixed number of packets from the queue at each tick of the clock. Okay. Now, if the traffic consists of variable length packets, then the fixed output rate must be based on the number of bytes or bits. Okay. Now, here, what are the problem with the leaky bucket? Because here, this leaky bucket is very restrictive. If a host is not sending for a while, its bucket becomes empty. And after some time, if the host has bursty data, the leaky bucket allows only an average. The time when the host was idle is not taken into account. These problems can overcome with the token bucket algorithm. Because in the token bucket algorithm, it is going to avoid the idle host. It is going to allow all the idle hosts to accumulate the credit for the future in the form of tokens. For each tick of the clock, the system sends n tokens to the bucket. The system removes 1 token for every cell of data sent. If n is 100, then the host idle is for 100 ticks. The bucket collects 10,000 tokens. Now you see if n is 100, here n is 100 and the host is idle for 100 ticks. Then the bucket collects 10,000 tokens. Now the host can consume all these tokens in 1 tick. Okay, that is with 10,000 cells, all the holes takes 1,000 ticks with 10 cells per tick. Okay, it is based on the requirement of the host. The host can send bursty data as long as the bucket is not empty. Now here, whenever we have this token bucket, it can be implemented with a counter. Always the token is initiated to 0. And each time a token is added, the counter is incremented by 1. Now, each time a unit of data is sent, the counter is decremented by 1. When the counter is 0, the host cannot send the data. And now what is mean with this resource reservation? A flow of data needs resources such as buffer, bandwidth, CPU time. It is called as a resource reservation. Here, if we have a concept called resource reservation, automatically the quality of service will be increased. And what is meant by this? Admission control. Yes, these are all comes under the sub-concepts for the quality of service. This admission control means it refers to the mechanism used by a router or a switch to accept or reject a flow based on predefined parameters called flow specifications. Before a router accepts a flow for processing, it checks the flow specification to see if its capacity and its previous commitments to other flows can handle the new flow. And the capacity in terms of bandwidth, buffer size, CPU speed, everything will be based on the capacity. Understand? Okay. See you in the next session.